All right, what's going on? Today we're going to be doing another list problem. This one's called merge two sorted lists. So we're basically given two linked lists called list one and list two. They're sorted in ascending order by their value. So as we can see, each list node is going to have a value, and then it's going to have a pointer to the next node in the list. And so these two lists are going to be sorted in ascending order. And they just want us to merge them into one list and then return that list. So it's pretty straightforward algorithmically. Well, really in terms of the time complexity, we know this is just going to be linear in best case because we've got to go through each element in both lists. So that's going to be linear with respect to the size of those two lists, right? How many elements are in them? We're going to have to look at all of them and compare basically to merge them. So really the only tricky part about this problem, I don't even know if you'd consider it tricky, but there are edge cases you have to consider. Basically you need to first look at, are both of the lists empty? If they're both empty, you can just return a null pointer, right? Because you don't actually have to do any merging. If one of them's empty, you can just return the other list as is, right? So those are really the two edge cases before getting into the algorithm. So let's go ahead and whiteboard an example just to get a better idea of what the algorithm is going to look like. So I'll just call this blue list L1 and then give it some nodes. So 2, 4, and then obviously at the end there, it just still has a pointer, but it's just pointing to null. And then we'll call the other list L2, and then I'll give it some nodes. So 5, 6, I'll give this one a couple extra nodes just to show it happens if they're not the same size. So L1, L2, and then it's basically the first thing we want to do, like I said, is we can check if they're both empty, then we can just return a null pointer. If L1 was empty, we can just return L2 as is, and then vice versa. So if L2, I don't even know, I forget which one I said at first, but basically if L1's empty, we can return L2. If L2 is empty, we can return L1. So after we have that out of the way for those edge cases where you have an empty list as input, we're basically going to want to create a new dummy pointer to keep track of the head of our new list. So I'll call this D, and this is just going to be a pointer. Obviously at first and that'll just be null at first. Obviously at first our pointers for the list, so we're passed in the pointer to the head of list 1, that's what they said. And we're passing the pointer to the head of list 2 also. And then at first for our new combined list, we're just going to be pointing to this first dummy node we allocated space for. So we're basically just going to loop while both of these lists still have elements. So while this pointer essentially is not here, we're going to keep looping. So the first comparison we're going to do is we're just going to check basically, is the value at these two nodes we're looking at, or which value is the smaller of the two values of these two nodes we're looking at. So the smaller value here is obviously going to be 1. So this dummy pointer is going to get pointed to this first node. So instead of being pointed at null, it's going to point to that 1. So to indicate that, I'll just put this 1 here. And then to indicate that this pointer is going to get shifted to be over here, to make that a little easier, I'm just going to cross out this node. So now we're here. Okay, so we're going to look at these two nodes now. So which one is smaller? The 2 is obviously smaller. So we can add that to the new list, or really we're just pointing this next pointer here. So we're going to add that to the new list. So now we can indicate that this node has already been looked at. So now we're at this node. The 3 here is going to be smaller. So we'll add that 3. And then we have a 4 and a 5. Once again, it's just checking which one's smaller. So I'll have a 4 there. And then notice our pointer now for this list is going to be here. So there's nothing in this list anymore. You know, we've reached the null pointer. So what do we do now? Well, instead of, obviously we're gonna have to return whatever this dummy node is pointing to next. And by the way, this white arrow wouldn't be there. As we kept updating this, this pointer would be here now. But regardless, as you can see, we're at a null pointer here. So once if L1 is empty and L2 is empty, which can happen, so if both of these lists were like the same size, then you could just ignore this part. But notice, you know, we still have elements here that we haven't merged. So once one of these lists becomes empty, we need to point this node basically to the end of this list. So maybe just to keep this video a little shorter, I'll literally just link this, because this is what you would be doing. You'd link this here, and then now you can return whatever the dummy node is pointing to next. So we would return this node as the head of our new list, and we can just return that, and that would give us the answer. So that's pretty much it in terms of the algorithm. So let's go ahead and get into the code for that. So as discussed, you know, the first thing you need to check is, are both of those lists empty? So if list 1 is null pointer and list 2 is null pointer, then we can just return null pointer, right? Because both of the lists are empty, we don't have to do any merging. Now the other scenario is, or other two scenarios is if, so now we know, you know, both of them aren't empty if this wasn't reached. So we'll check if one of them is empty. So if list 1 is empty, then we can just return the pointer at the head of list 2, and then vice versa, right? So if list 2 is empty, we just return the pointer at the head of list 1. We don't have to do any merging. So now to actually merge the list, we're going to need to allocate space for a new dummy node. I'll just call that dummy. So that'll be this will be the, it'll point, it won't be the head of our list, but it's going to point to the head of our list. So we can return it at the end of the merging. So dummy is going to be to allocate space for a new list node. We just do the keyword new, and then we write the type there, which is list node. So that'll create new space for that dummy node. And then we also want to have a pointer for that new combined list. So I'll just call it cur, and at first that'll point to that dummy node we just allocated space for. So we're just gonna loop while both of these lists are not at the final null pointer. So while list 1 and list 2, and we're gonna do a comparison on the values. So list 1 val, and we're gonna ask, is that value of list 1 less than the value we're looking at the node in list 2? So if it is less, then we know that we want to add that list 1 node to our new combined list. So we can just assign cur next to that list 1 node. And then we want to shift down the list for list 1. So list 1 is going to be equal, that pointer for the list 1 is going to now be equal to list 1 next, just to move down that list. And then we're going to have the inverse of that. So if the list 2 value is smaller than list 1 value, or if it's equal to that, in that case it doesn't matter which one we add, but we have to add one of them if they're equal. But either way, this will handle that case, and also the case where the list 2 value is smaller. So cur next will get assigned to the value in list 2, and again we need to move down the list for list 2. So that pointer will be list 2 next. And then after that, we also need to move down the list in our combined list. So cur will get updated to cur next. Basically, so we're moving down the combined list as we add those elements. So after we do that, there's 2 more cases. So before we can just return dummy next, right, we have to make sure both of those lists are actually empty. So because one of those lists could still have more elements, right? So we'll just so if list 1 is empty and list 2 still has elements, we're just going to return be, well, we're not going to return, but we're going to basically set cur next to those remaining elements in list 2. And then we can return. And then we also need to check the inverse of this, right? So else if there are not elements in list 2, but there's still elements in list 1, then we need to add those elements in list 1. So that's pretty much it for the code. And again, this is going to be linear time complexity with respect to the size of list 1 and the size of list 2. We're potentially going to have to look at every node in each. So big O of n plus m if you said the size of list 1 is n and the size of list 2 is m. So, but right, either way, linear and then constant space, obviously, because we just have a couple variables here that we created. And that's going to be constant regardless of the size of those lists that are passed in. So, so let's just go ahead and submit this and see the percentages. Yeah, so beats 81% for runtime, 41% for memory. So hopefully this problem or this video helped you understand this problem better. If it did, please leave a like and subscribe, and I'll see you guys in the next piece.